Imagine building a thriving outpost on a distant world, a place with a thin atmosphere, frigid temperatures, and punishing radiation. How would you power everything from life support systems to scientific instruments and communication arrays? It is a monumental challenge. For future human missions to Mars, the best energy sources are primarily solar power and nuclear power. Each has unique advantages and limitations, and a successful long-term presence will likely rely on a combination of both to ensure reliability and sufficient power. These two sources are dominant because Mars presents significant environmental hurdles for power generation. Solar power harnesses energy from the sun using photovoltaic panels, similar to those on Earth. However, Mars receives less sunlight due to its greater distance from the sun, and frequent dust storms can dramatically reduce solar panel efficiency. Nuclear power, specifically radioisotope thermoelectric generators and small fission reactors, provides consistent power regardless of dust storms or daylight cycles by converting heat from radioactive decay into electricity. The Martian atmosphere is also too thin for wind turbines to generate significant power, and geothermal activity is not easily accessible or widespread enough for practical use on a large scale. To effectively use these energy sources, mission planners must carefully assess the specific power needs of a base. For initial habitats and roving vehicles, deployable solar arrays can offer a relatively simple and scalable solution. However, for continuous, high-power demands, such as manufacturing oxygen or powering advanced scientific labs, nuclear power becomes indispensable. Engineers will design modular power systems that can be expanded over time, incorporating energy storage solutions like advanced batteries to manage peak loads and ensure power during Martian nights. One fascinating aspect is the development of compact fission power systems designed specifically for space. These small nuclear reactors, like Project Kilopower developed by the National Aeronautics and Space Administration, are engineered to be lightweight, autonomous, and capable of generating multiple kilowatts of power for years. This robust power source could transform long-duration missions, enabling sustained human presence and industrial activities without constant reliance on resupply missions for fuel or sunlight. Ultimately, securing a consistent and ample power supply is fundamental to making humanity a multiplanetary species. By strategically combining the widespread availability of solar energy with the unwavering output of nuclear power, future Martian colonists will be able to not only survive but also flourish and expand their scientific and exploratory endeavors on the Red Planet, paving the way for self-sufficient settlements.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.